Okay, good morning, everyone. It's the second CICS session today, 9 o'clock. I'm Rob Stroud. I'm your GSE UK chairman. Hopefully some of you have seen me before. We're going to have the chat open, and Nick Garrard from IBM is going to keep an eye on the chat if you've got any questions to raise. Unfortunately, you're all on mute at the moment. Otherwise, it gets a bit carried away. And we've got Colin Penfold here from Hursley. Colin, you're going to talk about what's new in CICS security. Take it away.
Indeed. Okay, thanks very much, Rob. Yes, my name's Colin Penfold. I'm the technical leader of CICS security. Now, I've been in IBM for almost 40 years now, the last 30 of those within CICS. So what I'm going to talk about is what's new in security in CICS TS 5.6, the most recent release, and also the CICS Open Beta. Most of the information will be in the CICS from things that we've done in the CICS Open Beta. The presentation structured in 4 parts. I'm going to talk about, first of all, our enhancements that we've made to TLS. Then go through some securities and scenarios and best practices. Following that, I'll be talking about enhancements that we've made to security monitoring and ways of preventing threats to the region. And finally, I'm going to talk about simplification and improvements in diagnostics, in which I'll also attempt to give a demo. Now, for those of you that are unfamiliar with the CICS Open Beta, this is something that we've been doing for the last decade. About every quarter, roughly, we release a version of the Open Beta, and that's a free-to-download and try version of CICS. And it also comes with documentation that you can get on the IBM Docs website talking about the beta. So most people look at the website rather than download to get an idea of what is probably coming up in a future CICS release. Obviously, usual terms and conditions applied as it's a beta. What we're trying to do is get feedback from everybody, and things may change depending upon that feedback. Now, one of the principles of this open beta, we've got security objectives in a number of areas. We did quite a lot of customer research with various customers at the beginning of the release. And what we were looking for is what was taking the most time and causing the most problems in CICS security. And as a result of this feedback, we come up with a plan looking to do simplification in 3 primary areas: diagnostics, simplification of diagnostics, simplification of configuration, and simplification of helping customers with compliance. So first section is about enhancements to TLS. There are 4 areas that I'm going to talk about. First of all, something that's in 5.6, which is the SNI support, outbound SNI support. And then 3 items in the open beta. And you'll see on the heading slides for each of the sections, little daggers to indicate these are open beta items. So we've got something of the about TLS 1.3, enhancements to monitoring and statistics in the TLS area, and also some improvements in the diagnostic messages. First topic is outbound SNI support. Now, this is something that a number of customers requested. SNI is something that allows a client to contact a server which has a single IP address, but is actually a virtual host. And it enables the virtual host to supply the certificate of the virtual site that is being hosted on that single host to provide that server certificate, rather than the certificate of the virtual host itself, the host itself. And this comes in, for example, with Amazon Web Services, and it's sort of an example of the sort of thing that SNI support is useful on. So CICS is supporting SNI as a client so that we can go outbound to a server that supports SNI and get the appropriate certificate back. It's supported without any configuration being required. This all happened under the covers, and it is something that we have retrofitted because of various customer demand back to 5.3 in APAR PH 263. Now, I'll just show you exactly what SNI is all about. So without SNI support, you get a CICS client issuing a request to virtual host A, or another client issuing a request to virtual host B. In the first case, there's a URI map, which has got a host name with the A server. And the second case, you've got a host name of the B server. When a request goes out, the DNS server identifies the address, which is both the same because it is the physical box of the server, and the request goes to that. And what will come back is that server certificate. So there's no way that either of the clients can identify that they're definitely talking to the virtual host A or B. All they're talking to is the server. With SNI, it's rather different. We put some additional information in the TLS handshake, and that enables the SNI server to understand us and return back to us the certificates of the virtual host. So instead of the server certificates, we now get the virtual host certificate A or B, depending on who's being talked to. So this all happens under the covers and enables one to talk to SNI-enabled servers. In the CICS TS Open Beta, we now support TLS 1.3. TLS 1.3 is a fairly recent RFC, recently approved RFC, and it is a major change to the TLS protocol. CICS has been supporting TLS or its predecessor SSL for many, many years. We're a very early adopter of SSL. TLS 1.3 is a rather different departure to the normal upgrades. Normally, when we do an upgrade, when there's an upgrade to TLS, things are very compatible with the previous versions of TLS. TLS 1.3 is a rather different beast. It's got a number of new, much more secure ciphers, of which 3 of them are supported by system SSL that the CICS uses. But these are all incompatible with the earlier ciphers on 1.2. That, I say, is a departure in terms of the spec. There are a number of changes to TLS 1.3 to make it more secure. There's a single handshake with more information encrypted. The algorithms are more secure algorithms, but there's also changes in terms of how TLS supports caching. Now, as I say, CICS was a very early adopter of SSL and TLS. And when we first came out with it back at the end of the 90s, we had got a method of defining the support, which was using a parameter called encryption with strong, medium, and weak, which was, in hindsight, not a very good idea, because where do you go from that? Do you go stronger, strongest, even stronger? It just doesn't work. And as a consequence, a while back, we made some changes so that we've got something called minimum TLS level. Because encryption is something that is a really old piece of technology, the highest level of TLS support in the encryption SIP parameter is TLS 1.0. We've now, rather than deprecated, we've removed that SIP parameter. And so in order to use TLS, you have to code or allow to default the minimum TLS level. We've also introduced a maximum TLS level. And the reason for this is because the migration to TLS 1.3 is a little difficult. We've set the maximum TLS level at 1.2. This is a departure from previous practice where we always supported the highest level available. You actually now have to opt into the next TLS level, and I'll show you in the next files why that is necessary. One of the things that is different with TLS 1.2 is it doesn't support any of the old 2-digit ciphers. And as a consequence, the work that we did several releases ago to encourage people to use XML files to store their ciphers is now something with TLS 1.3. It's now mandatory because we cannot support the older ciphers. That has meant that we've had to introduce a new cipher set called default ciphers, and this replaces the default numeric ciphers you get when you do an RDO definition at the moment. So as long as you put a default ciphers file in with the ciphers that you want, when you create an RDO definition, it will by default use those set of ciphers. Now, there's a number of steps that you've got here that we've got in the IBM docs, which one needs to take in order to move up to 1.3, TLS 1.3. You need to be running on ZOS 2.4 and run the open beta or whatever release comes out after this. Also, you would have to create and customize the default ciphers XML file and make sure all of the resources are using this XML file. You can use the resource overrides feature in CICS to do that in an easy way. And also you need to make sure that the certificates have a sufficiently long key length. After all of that has been done, then it would be safe to upgrade the maximum TLS level to 1.3. And I'll show you in a little bit with some stats, some work that you can do to help check that in the next foil. So we've made changes to TLS monitoring and stats. And the reason why we've done that is from talking to customers, one of the difficulties one's got is trying to upgrade in a safe way your minimum TLS level, or upgrade in a safe way the ciphers that you're using by removing a cipher. When you make a change to the minimum TLS level, obviously what you're not wanting to do is to break any applications while you're doing that upgrade. It may be the case that you're talking to a client or a server that only supports the level of TLS that you're wanting to migrate from. That does happen. So to make it easier to do the upgrade, what we've introduced is some stats. So you run the stats for an interval, and it will tell you over that interval what connections, what protocols are being used for all of the handshakes that occur during that SICS interval. So an example here is the STUP output, and it shows that during the interval, there were no TLS 1.1 connections, there were TLS 1.2 inbound connections, and TLS 1.3 inbound and outbound connections. And if you run it over a sufficient interval, that can reassure you that you can upgrade from TLS 1.1 to TLS 1.2 as your minimum TLS level. Similarly, it gives you the inbound and outbound ciphers that are used on handshakes. If, however, you do find that something is using the minimum TLS level, the TLS level that you want to upgrade from, you can then run monitoring and try and find out which of your connections are using that old protocol. And so you've got here an example of an inbound monitoring record. In the performance monitoring record, you can see there's TLS level 1.3. It also has underneath there the cipher that is being used, which is cipher 1301. There's also information for outbound requests, and this is on the URI map resource entry. And for this particular case, one can see a cipher of 35 being used, and just unfortunately the bar has slipped there. Just underneath there, there's also the TLS level. Now, from this information and other information in the performance record, you can find the client or the server that you're talking to. And when you're doing the upgrade, obviously, if you find a client or server that is using that old protocol, that will then tell you the client or server application that you have to upgrade before you can move CICS on to the higher minimum TLS level. So finally, in the TLS area, I'll talk about the diagnostic messages. Now, in our wisdom, we tended to issue a message which was for TLS errors for just about every single TLS connection error going, whether it's inbound or outbound. And this was message DFH SO123. And this contained information about the return code that we got from System SSL and a few other bits and pieces of the function that we were using. But it's not exactly something that is consumable for newer system programmers to understand what needs to be changed. The information's all there, but it's not really easily consumable. And so the feedback that we got from doing our research is it takes us a lot of time to try and work out what we're supposed to do on a lot of the common errors. Can you make it easier for common errors to tell us what's gone wrong and what you need to do? So we've looked through various common areas, various things to do with certificates failures, certificates having expired, or various other types of common problems. And we've separated these out into where CICS is a client and where CICS is a server, different messages preceded by DFH SO03 or 04 for client and server. And in each of these messages, these are sort of common error scenarios. We've given guidance of exactly what you need to do to fix the problem, or exactly what you need to do to diagnose the problem. So there's a lot more information, much more specific for the particular problem. We've left 1, 2, 3 there, and that is more for the more obscure errors that you would often need to contact IBM support for. So that's the end of the TLS section. The next section is about best practices and scenarios. Before I do that, was there any questions on the chat, Nick?
Hi, Colin. None so far, but I'll just reiterate, please, if you have any questions, please put them into the little chat box at the bottom and we'll get Colin to address them. Thanks,
Okay.
Colin.
So next section, is about scenarios and best practices. And in there, I'm going to talk about various things in the open beta, our changes to the security documentation, enhancements to the health checker, and something called region tagging, which may seem a little strange in a security presentation, but I'll explain why. So the security documentation has built up over the last 40 or so years within CICS. And it appeals to some of us older system programmers. When it's in sort of book form, you've got about 500 pages of security documentation. But in reviewing this with various customers, in particular, younger, the newer system programmers, it's not exactly consumable for them. The education that they've got from university and they're picking up is rather different in terms of terminology for security. And the way they consume information is very different to the way that traditionally we've consumed some of this security information. In addition, we frequently get requests from application architects trying to sort of help guide them through various scenarios that they're trying to create and what we would recommend. A lot of this in the past has gone to Montpellier to sort of get advice. What we're trying to do is to try and rework the documentation in a form that is going to be useful and consumable to newer system programmers and also these application architects. So we're in the process of restructuring all of the security documentation. That doesn't mean sort of removing things. It's changing the order and changing the way that we describe things to make it a lot easier to use. So you'll see in the beta documentation, the open beta documentation, two sections for security. One is new doc and one is old doc. And as you may have noticed during the period of the open betas, things gradually move from old doc to new doc. So you can guess what's happening. The new doc is structured in a way that it's got an education section at the beginning, signaled by how it works. So these how it works sections describe the various concepts of security to a newer person. So all of the various things and what they actually mean within CICS and what the terminology is that we use within CICS. After that, we've got various sections to do with capability. So the various types of capability within CICS and how security relates to them. So what is security in SOAP Web Services? What is security in Liberty? And inside those sections, there is how it works, a basic overview of what security means to that various capability. And then there will be a series of design examples which will show various common scenarios that we understand from customers. And this in particular, we've talked to the Montpellier group to sort of understand where they've been given advice and are testing things out for customers. What are the most common customer configurations? Gradually, we're also including configuration for those design examples. So there will, over time, be configuration for each design example. Now, this is fairly unrecognizable from the old documentation, as you will see when you look into it. One of the things that we're gradually getting through is having diagrams in a common format which show the flow of all of the various artifacts in security, and it will show the user IDs as they flow through the system. It will also show the security aspects of resource definitions, SIT definitions, and MACF definitions, so that you can see everything that is appropriate to a particular configuration. And to explain it, we're starting to make use of swim lane diagrams so that you can see the exact flow from the end user, the client user, all the way through to CICS and how their security works for a particular configuration. So some of this is in there at the moment, but this is the sort of pattern that we are working on to improve the documentation so as to make it easier to consume. And we'd very much appreciate any feedback to this. I've got at the end of the presentation a series of links, but if you read the security documentation, have got any feedback for it, we very much appreciate that. One thing that is new in the way that we're writing this documentation is we're putting recommendations very visibly in the documentation. Now, there are a couple of types of recommendations that we've got. Some are recommendations which is really just sort of advice, which is based upon what we've seen in customer setups as a good way of running things. Also, sort of, it may be advice from an auditor of how you should run things. And in addition, there's some slightly stronger advice, which we call best practice, security best practice. And in there, we will also check with the ZOS Health Checker that your systems are running with that best advice, that they conform to that best advice. As much as possible, we try and put in here reasons why we are recommending a particular configuration. So that moves me on swiftly to the IBM Health Checker. So the IBM Health Checker is something that's been around for the last decade, roughly, and it's been switched on by default since ZOS 2.1. The purpose of it is to check the configuration of your ZOS system and recommend best practices. This is something that is not just a CICS thing. It is many products have got health checks, and in total at the moment I think there's about 150 health checks on ZOS. The health checker can be seen in SDSF. There's option CK to display it. And so if I have a look at CK, option CK, you can see in here a number of health checks. These ones aren't the CICS ones, but are useful as a demonstration of what the scope of the health checker is. So MACF has a series of checks, checking various things like the encryption algorithm. It will check things like the password interval, things of that nature, which are recommendations and hints of how to make your systems more conformant. Now, if you type S against one of these things, you get more information about whether something is conformant or not. The other information that you've got is on the status side. You can see whether your systems conform or don't conform to the health check. So we've got one here, which is the certificate expiration, and you can see that that has got an exception medium against it. So if I clicked on, selected that one, certificate expiration, and open that up, what it will tell you is all of your certificates that are about to expire within 60 days. And these are certificates that are defined to MACF, or certificates that have expired. Now, this is an extract of our system, and as you can see, we've got rather a lot of very old certificates that we should really be cleaning up. My predecessor, who retired nearly a decade ago, still got some of his certificates in there. So CICS has conformed to the participated in the health checker for a few releases, and we originally put in 3 health checks which were there because of a hacker reporting a method in a public conference of how to hack into a poorly configured CICS system. This was the pen test tool CICS PWN. And what that was all about was finding a CICS region where the default user had got access to certain resources, which is something I hope most people would never do. But he did find some systems. So what we've done is we put in health checks to warn about that. So if a default user had access to CEDA, which is fairly obviously a not very safe thing to do, then we would give a warning. Similarly, if you're able to use KEKI, it is possible to execute commands and write JCL to the spool, provided that has been defined in the set, and that would give the ability to submit JCL under the CICS region user ID. Now, there have been fixes that have been put in to prevent that anyway. So there's different ways of configuring things. So there are set parameters to prevent you from submitting JCL or authorizing you when you can submit JCL, and under whether it's going to be the CICS region ID or the task ID. But these checks still remain to check whether you are still doing things under the default user ID. But in the open beta, we've introduced a lot of new checks to check on the configuration, and these are based on best practices that we've talked to auditors about of what they would recommend a CICS system to be configured with. In particular, these are things that you would configure a production region with. Test regions may vary on certain customers, especially if they're totally isolated from the production regions and production LPARs. The type of configurations that we've got, type of health checks that we've got, are configuration for region definitions, so the SIP parameters primarily, CICS resources, best practices in resource definitions, and also ZFS security. So the sort of examples that we've got there is a fairly trivial one. Have you set security yes on your SIP parameter? If it hasn't been set and it's a production region, it is not conformant. So that's a fairly obvious one, and that would be a very high risk thing not to have configured. But there are other ones that I have actually seen in customer configurations that when doing a health check, things like, have you got surrogate security checking on, and have you got transaction security checking on? So in red there, although they don't appear in red on the CK screen, the health checker screen, are the new CICS checks. So there are 4 of them. And if you look inside those, you will see each of the regions that have got 1 or more errors with them. And each of those regions will then, inside the health check, you will see with a message exactly what the health checker is complaining of. So for example, in this one, the first region that has been talked about here has got an exception message which says xtran equals no has been specified, a fairly basic error in the configuration. And then it's got a warning message. So this is not as severe, but is a bit of a recommendation that the minimum TLS level should be higher than the level that it's set to. So a level lower than 1.2 has been specified. Associated with those messages, there's obviously help in the IBM docs describing in more detail what you need to do and what the problem is. Now, one of the bits of feedback that we got from the health checker was, and this is not just the CICS health checker, this is the health checker in general, is it's got some really good advice, but sometimes you can't see the wood for the trees because there are many of its recommendations that may not apply to a particular customer configuration. It may be that you've got other processes in place to have the equivalent level of security. So what we wanted to do is to identify some way that we could, in an auditable way, exclude certain health checks from these new CICS health checks that we're introducing, because we're introducing a fairly large number of health checks, and we didn't want to flood the system with unnecessary errors that you would then ignore, thereby hiding the important information. An example of that sort of thing is you probably wouldn't want all of the information on the test regions. You may sort of separate out test regions so that it's only the production and production-like regions that you really want reports on. In other cases, there may be particular messages that you don't want to see. So what we looked at is some way of identifying this, and we came across really a problem that a slightly alternative solution, rather than just looking at the health checker, would give a bit more information. And this is something called region tagging. What we had got looking at was the problem is trying to identify what a CICS region was. Was it a production region? Was it a QA region, etc.? What type of region was it? What part of the business was it responsible for? Possibly what application was responsible for it, or who was responsible? And doing health checks on customers, I've seen this information when asking to see what regions have you got, and trying to sort of identify what regions I really needed to check. This information generally was available in some spreadsheet or Word document or something like that, specifying some form of naming convention. But it was quite difficult to use in terms of an operator would have to refer back to this document if he was wanting to know what a particular region was used for. So we come up with the concept of region tagging. And here you define in a file, a YAML style file, your naming convention. So in this particular file, we've got what is a region used for? It's a development region if it's got a D in the fourth character of the Apple ID, or it's got a P. If it's got a P, it's a production region, and so on like that. So it defines what the region's used, the region usage, whether it's production, development, etc. Or it could be a region type. You can define those to say whether it's a TOR, AOR, etc. And other information in there you can have user definable tags. So you may have something which is a tag to say the responsible person, and defining that by using the naming convention that you use. And that naming convention can be based upon the Apple ID or the region user ID or the job name, because when we've seen these, those are the sort of three things that people have used to do their naming convention. Now that is coupled with a browse SPI, so that you can display what tags there are on a region. And the browse SPI will come back with a series of tags such as CICS TS region usage production. And that can be displayed in the, or that will be displayed in the Explorer as well. So you can see a particular region and what it's used for in a new view in the Explorer. Sometimes you may need to refresh the tags because you've added new regions, and if you need to change things for a particular region, you've got the ability to refresh the tags without having to restart the region. Now, the other part of this was the excluding the health checker information or messages. So inside the tagging file, there's another section which is Exclude Regions. And you can see here that in our version of the health checker here, our example file, we've excluded any regions which are development regions or sandpit regions. So they just don't issue any messages to the health checker. As I said, not all of the messages that we issue for the health checker may be of relevance for each of the customers. So we've given a file here of all the messages that we issue as part of our sample YAML file. And just by uncommenting the file, one of the lines on the file, you can stop a message from being issued. So in this case, there's a recommendation that command sec should be as is. It's a fairly low recommendation, but it is one of the recommendations that we've seen from some auditors. So it's there as a recommendation. But if that doesn't apply to your system, you can uncomment that and that message won't be issued. But the auditors, if they're looking at your system, can come in and see your YAML file and will be able to see, right, that's the reason I don't get any of those messages. Let's have a look at how your other processes to make sure that command security and resource security is sufficient. So that's the end of that section on scenarios and best practices. I'll fairly quickly go through the next section, which is about monitoring and preventing threats. CICS security statistics didn't exist when we originally created the security domain many years ago. And one of the reasons for not having any monitoring in there was just because all of the methods that you used for doing the all the methods that were used for authenticating to CICS were very quick. So there was no need for any monitoring information, which is normally to diagnose problems. However, things have changed over recent years so that you've got a number of ways in which you can authenticate. It's not just the password and pass tickets of the past. You've got MFA has come in. JWTs, at least MACF JWTs was something we introduced in 5.6. Kerberos is also there. And so what we've introduced is some new monitoring and statistics in the security domain. So these are the statistics that we've got. And what this gives you is information about the number of ACEs that are used. These are ACEs that have got, on the right-hand side, just normal user ID ACEs, the security tokens, how many you've got in the system and what the peak numbers are. And on the left-hand side, it's got the ACEs with ICRXs, which are ACEs with distributed user ID information on them. So you can see the usage of these control blocks. Underneath that, you've got various information about the number of authentication requests that you have and the types of authentication requests, how many are fast path authentication requests using cached information, how many go to the MACF database. Similarly for authorizations, the successes and failures. Obviously, the successes, the failures information will be in the MACF SMF records as well. And finally, for something that we introduced recently, there's data on if you're issuing too many security requests in parallel, we throttle the amount of security requests that are issued to 1/3 of max task. And the reason that we do that is to avoid sort of bottlenecks. If you've got a lot of MFA requests, for example, going out to an outbound server and there's a slight hiccup there, what we don't want to do is bring down the CICS regions because of the number of requests that are elapsed requests that are waiting for that MFA server. So as I said, that we've also introduced some monitoring, and the purpose of this is so that you've got information for those security requests that take rather longer time. So there are 4 fields that we've got. The first one is to do with password, the verified password requests. Typically the things that would have longer times would be the MFA requests, if you've got any of those. And then there are the other types of authentication within CICS. There's a verified token API, and that can support basic authentication tokens, Kerberos tokens, and JWTs. And we will give information on the performance of those requests. Next section to talk about is about threat protection. A common problem in non-ZOS servers is code insertion, whereby a request is sent in and inside the data is some code, and the server is conned into executing that code in some way. Now, it's difficult to do that on a ZOS system, but not impossible. So what has been introduced in the Z14 is a way of separating code from data, thereby giving the ability to prevent things from running on data, which prevents the code injection that, I say, is so prevalent on other types of servers. So storage is separated out into either executable storage or protected storage. So that is data storage. Now, the threat that you've got before instruction execution protection is you hide some code in the data and then somehow have a program which branches to that data and executes code which has never been approved to be run on the system. So in this particular case, you can see that I've introduced some well-known instructions in a piece of data in red. In order to implement this, we've had to make a change to the storage areas that are used by CICS. Some of the storage areas were used in the past, both for data and for program storages. So the DSAs in 5.6 were RDSA for re-entrant programs, which could be key 0, and so therefore definitely protected. The SDSA, which had shared user key storage, but also user key programs. And the CDSA, which was CICS storage and CICS key programs. And these were non-re-entrant programs that you could have inside CICS. And finally, there's the UDSA, which is purely for data. Now, for those DSAs which are contain both programs and data, we've separated out the usage of those. So now there's a PU DSA and a PC DSA for programs in user key and CICS key. And that replaces the CDSA and SDSA storage areas for those programs. So if you use those types of programs, they will now be put into an area which is separate. And if you switch instruction execution protection on, and you try to execute anything in the data storage, you'll get a failure. Now, in order to do this, you need a Z14 and ZOS 2.4 or 2.3 plus some APARs that have been out for a while, so you probably have got those in system, and therefore, and also configure the CICS system with some feature toggles to say I want execution protection on. And the idea of this is that vendors and customers can test out their code to see whether there are any problems that you've got where you're executing data storage, and allow customers to rewrite, vendors to rewrite their programs. It's usually going to be vendors rather than customers doing things like this, to rewrite their programs so as to make sure that data storage and program storage is separated. And if that has been done, and then you switch on instruction execution protection, your system is much safer because it is protected from these code insertion types of hacks. There are some very rare cases where one does need to have storage which the data can be executed. This in particular happens with vendors, some vendor code, and for that purpose we've got some special APIs that can be compiled with the CCIB, where you can get that type of storage. Finally, I'm going to talk about some enhancements that we've made to diagnostics and simplification of configuration. The first of these, when talking to customers about what takes them a lot of time, one of the things that took a lot of time was setting up CICS regions and their security definitions for the Cat1 transactions. Now that got me thinking, because I was rather surprised how long it took people to do that. But I've been thinking about this for a while, of why do we need these Cat1 transaction definitions, security definitions in the first place? Because CICS knows the region user ID, it knows what is a Cat1 transaction, and it knows how a Cat1 transaction started. It cannot be started from a terminal. If you do that, you get an append. So why are we actually asking you to define definitions to the security manager, and then us asking the security manager, can we run these transactions, which are really part of CICS code? So what we've done in the open beta is we've removed the need for a security check for the Cat1 transactions. That's all done internally within CICS. We know all the information. If it started with a different user ID or in a different way, we will append. And by doing this, it makes things more secure because you cannot misconfigure things. So it's a win-win in both ways. It's a bit quicker, but most importantly, there is no need to do the security definitions for Cat1 transactions anymore. And as a consequence, the Cat1 C list has been removed, so you don't have to run those things anymore. Auditors often are very keen in checking all of your Cat1 definitions, so we've made it clear in the auditor's guide, or making it clear in the auditor's guides, that that is checked internally by CICS now with an appropriate append. So hopefully that will reduce the amount of work that is needed. And it will also mean it is easier now to ship system transactions in the service channel without breaking you. Because in the past, if we did ship one of those, we did it very occasionally, and inevitably somebody missed the plus hold information and a system wouldn't come up, or would come down fairly swiftly afterwards. The next thing that we'd got, we were investigating various types of security problems that customers had and things that took them a while to diagnose. And there were sort of two flavors of these types of security problem. One of which is you've got messages out, ICH messages, ICH 408 messages, or XS 1111 messages out, and you wanted to try and find what was causing those messages, the end user. You know, the basic information in an ICH 408 is very simple. So you've got on here, it tells you who hasn't got authority for a particular profile in a particular class. However, you don't necessarily just want to give them authority to do that, because there may be a problem. You often need to find the end user or the end client that was instituting a request that generated this security error. But there isn't enough information on this message. In particular, if this is something that occurs on an AOR or an FOR, you've lost the information about the original client. And so it takes people a while to try and get the origin information. So what we've introduced is a new message, XS 1117, which accompanies an XS 1111 message and gives information, all the origin information that we have relevant to that request. Now, the information that you've got obviously depends upon the actual origin. So if it's a web request, you'll get different information if it's a terminal request that has been routed to this particular region. But you should have in this message all of the information that you need to identify the actual end user. In some cases, it may be that the user ID has changed as it's gone from one region to another, and it will tell you the original end user. If it's got a distributed user ID, it will tell you that distributed user ID as well. So that should make it easier to diagnose those sorts of problems where you see a message and are trying to find the end user. But there was another sort of problem, which typically is rather rarer, but when it occurs, is very difficult to diagnose. And this is the sort of help desk problem where somebody's reporting an error and you may not get any symptoms, or you may not be able to find the messages that are occurring. Now, this occurs because obviously with a CICS system, you can have many regions and work is dynamically routed to various regions as it goes through the system. You may have functional user IDs rather than the end user's user ID. You have link user IDs that sort of will change the user ID as it flows through the system. You may have started tasks. So the reason that the failure is occurring is something that way down in the AOR, a task is started and that one gets the security failure. And it's very difficult to see from the end user point of view or the initial operator's point of view where the problem is. So these are the sort of problems that are reported to the help desk, and it's basically something's not working and sort of no messages come out. There is a similar problem where in test, where something's working and shouldn't be. And that's even harder to diagnose, because if something's working but shouldn't be, obviously you don't get any messages at all out on that. We don't report, yeah, it worked okay. And often on some of this, because of the way that the CICS works, you don't get any trace either. So we've had problems of this sort of nature that have been reported, gone through IBM service, and have been taken weeks or even months. One of them I know of took 9 months to solve, a whole series of slip traps, etc., to try and diagnose what the problem is. So why are we having these sorts of problems? Well, CICS is very flexible in its configuration, as is MACF and other security managers. And you may not get messages coming out. There are various reasons that you don't get messages or security checks done. CICS can be defined so that security checks aren't done at the SIC level or at the region level. And the ESM can be defined so that it doesn't put out messages for ICHs. You can specify the definitions that you don't want anything logged. CICS can also do that itself in certain circumstances, like the query security command. And the MACF exits, and also the additional complications where you've got multiple security managers. It's very difficult to see what's going on there. So what we've introduced is something called security request recording, where an operator can switch on a security log for a particular origin. So it may be the transaction that somebody's running for, and it's a particular user ID that is running it. It may be the case where you've got something coming in on a particular TCP/IP address or a particular port. Whatever the origin information, you can specify the origin information in the security command and say, I want you to log all of the security requests for a number of instances of these requests and log it throughout the system wherever it goes in a common log or a common set of logs. So we will record things. We'll switch on something when the request comes into CICS, and that will be flagged so that it will write out information at the end of a task for each of the transactions to a journal, which is a secured journal. So then the system programmer or whoever's investigating the problem can look through that to try and diagnose the problem. And this will be a problem that is in multiple regions, potentially multiple tasks, but all related to a single origin request. And what one does from that is, once you've captured the information, that information, you can run a job and the information can output to ZFS and displayed in a spreadsheet for diagnosis. And I'll finish off this presentation with a little demo of that. And here I've got a setup where I've got one region which DPLs to a couple of regions and then does starts to those regions. And so we've got something where somebody has suggested that they've got a problem. So if you bear with me, I will show you my CICS region. I will log onto that CICS region and I'll run a command which failed in some way. So I'd report that to the help desk, and the help desk would set security request recording. GSE is the name of the tag that I'm giving it. So I'm giving it a little tag to identify the bit of the trace that is relevant. And I specify some information to how many times I want the thing recorded. And I specify, in this case, I know it's transaction SOR0. I'm not specifying anything else, but you can limit things to as much as you want to. So I issue that request, run the transaction again. This will have triggered, and I then will run a print job, and I'll specify in it the ID that I specified before. Run that print job. And if I look at the print job, I've got various information in here. One, that's the request I issued. That's all of the origin data, or some of the origin data related to it. Then down below, one can see that request went to 3 regions, and that is all the security information, security configuration for those 3 regions, which may be useful in diagnosing the problem. But the most useful information comes from what has happened in a spreadsheet that's been generated. So this CSV file has been generated, and I will launch that in my spreadsheet. The moment it's not sorted, so I will just start off with doing a simple sort by Apple ID and by Apple ID and Tran ID and Tran num, and then I'll show you the information in that spreadsheet. So you've got in here the regions that will run on. The original request was run on first region, SOR1, and then regions 2 and 3 were involved. You will see here the security requests that were done, the profile in which class a security request was issued. You'll see there the access level and whether it worked or failed and the reason why it worked or failed. So in this particular case, there was a failure, and that failure was a query security command. Now, if you looked on the log, you would see no message on the log for that. Down below, you see other cases. So there's a failure, a standard failure. It tells you the user ID that failed, and you've got information on that. And some cases, something worked. So this surrogate check worked, and the reason it worked was the X-user SIT parameter was set. So you've got all the information on all of the security requests for all of the tasks that were started by this original SOR0 request. So there's a whole series of tasks, whole series of security requests. And the final thing I sort of mentioned about this is it's only recording the security requests, nothing else. It's only recording information for that origin information. And so therefore it is a lot faster than running a trace, and therefore suitable for production use. So I think I've got to my allotted time, as Rob has just popped up in the window. I can see his video. So apologies if I've cut short any time for questions, but up to you whether there are any.
There are none in the chat box, so I think you're clear, Colin. You are obviously crystal clear in your presentation.
At the end of the presentation, I've got some links which are, if you've got any further questions on anything from the open beta, please ask the community there, and also links to the open beta education.
Thanks, Colin. That was a very interesting demo. Just going to wrap it up with an advert for the next session, which is back here in virtual room 4 with another stalwart from Hersley, Mr. John Tilling, who's going to be doing the CICS Foundation update. So if any of you are interested in that, I'll see you back here in 28 minutes. Thanks for your time, everyone. Thank you so much, Colin.
Okay, thank you very much.
Appreciate all your efforts, and see you soon.
Bye.